Okay, I will clean the board. Chebi, I can clean the board. So because today's one, today's one is, you will come and be teaching us. So check the questions on the group. Check and you come and teach us. I know I taught this thing yesterday. I'll just recap. Then once I'm done with the recapping, I will point you. You come and teach us a question. You teach us with a question on that group. So others will pay attention to you. So when you are teaching us, you make sure you are writing bold so that camera can capture you, because whatever you are teaching us, others will watch it. We told you that this is 2025. This is the semester you'll be writing exam. So we believe this is the year you'll be writing exam. We believe that it's not all about us teaching. You have to be proving it this time around. So make sure the one you are choosing, even if somebody choose your own before you, you look for another question there that you will solve for us. That's not today. Everybody must do something. Oh yeah, please just watch, pay attention. Let me recap so that as you're coming to solve, you use it as a guideline. Okay, see, the only thing I'm giving you, please, is this. We have what we call rules of dimensional analysis. The rules of dimensional analysis. And we said yesterday, we said that the first rule is that the left-hand side, the first rule, must be equal to the right-hand side. What this thing means is that if, for example, I am told to solve something. Let's say they tell me that we have T equals to NL, or let's say we have LG. This can be a question. I said that the first rule is that since I'm having T here, I'm seeing L for length. And I know that if this is the case, T is equals to L, and G is acceleration due to gravity, is having LT raised to power minus 2. Notice that I don't have M here, but I have L and T. But notice that here I have only T. Left hand side must be equal to right hand side, in that I will not say M raised to power 0 and L raised to power 0. Any T raised to power 0 is 1, is it not true? Yes, so it means that this is 1 times 1 times T, which is the same thing as just the T that I have this side. I will do the same thing for this right hand side, so that I will say the only thing I don't have here is M. I'll now come and do M raised to power 0, LT raised to power minus 2. So what it means is that all the dimension I have on the left hand side must be on the right hand side. And how do I do that? By using the law of indices, which states that any T raised to power 0, zero power law, is equals to 1. That is the first principle. Now, the second principle you need to understand is, again, that once I am adding up Once I am adding up dimension, or once a question comes, and that question is addition or subtraction of dimensions, I will tell myself, for the fact that it is being added or subtracted, that it is the same thing. This is what I mean. We used an example of ray gas yesterday. We said, for example, P minus A over V square. Then we have V minus B equals to RT. This is ray gas equation. Now we said that if we have this, please remember this is the first rule. Left hand side must be equal to the right hand side. We are on the second rule. Now we said that if we have something like this, notice that right here, A over V square is being subtracted from P, pressure. Now notice that this is B. Sorry, this is supposed to be plus. Yes, this is V minus B. For the fact that this is being subtracted from here, I will use the principle, which is if I have X plus Y, it's not possible to add it up. It will simply be X plus Y like that. But if I have X plus 2X, I will definitely have 3X. Is it not true? Yes. So if that be the case, this is the principle I'm using, that for the fact that this thing is given to me, it simply means that what I have here, if they tell me to find A or B, it simply means that what I have here is the same thing with this P. And for the fact that they are giving me this to be subtracted from volume, that means that this B is volume, while this A is simply product of pressure and volume. So what I will do in this case is to apply the law, the second law, which says that the addition or subtraction of a quantity is equal to its dimension. So the addition, if I'm having a quantity being added or subtracted from a particular quantity, its dimension is the same. That's the rule. So I will simply say that this is the same thing as saying P plus A over V square is equals to RT, and V minus B is equals to RT. So employing the principle, all I will just need to do is to say take the LCM of this. And if I take the LCM, I want to clean this. If I take the LCM, you can immediately see that P plus A over V square equals to RT. I'm putting the RT, if I want, I can call it 0, but I told you that this part has no use for the fact that this is what we are doing, addition. So if I take the LCM, you see that this becomes V square here will be PV square. V square here will just be plus A. Is it not true? Equals to RT. And if I cross multiply anything standing on this one, this will be simply PV square plus A equals to V square RT. So my business now, remember my business is to find A. They did not tell me to find the dimensional analysis of everything here. They are asking me to find A. So for me to find A, I will simply say anything I find this PV square to be is the same thing with this A. Which is why we started with that principle of if I have X and 2X, it will give me 3X. But if I have X and Y, I cannot add it, I cannot subtract it. So for me to be given this, it simply means that A is this thing. But I already know this one, but I don't know A. That is what it means. So I'll ask myself, pressure is force over area. Is it not true? Now volume is raised to power 3, meter cube. Now when it's square, it's going to be L raised to power 6. Now force is the same thing as saying MLT minus 2. This is not strange. All over L square times. So by the time I do this very well, you see that this will cancel this. Is it not true? Yes. So that I'm left with, and notice again, this will cancel this and it will remain 5. Should we agree? So that I'm now having ML5T minus, yes, T minus 2, that is it. So that is what I have when I times pressure with volume square. So I just have ML5T minus 2 plus A equals to V square RT. It's the same thing as saying once I'm solving here, ignore everything on this side to find A. My business is simply applying that rule that for it to be added or subtracted, it means that they are the same thing. So A will simply be equals to, this A will simply be equals to what I've gotten. So A is simply equals to ML5T minus 2. Somebody wants to tell me, but sir, why didn't you make A crossover to become subject formula? What we are doing here, once its dimension is not to make A or B subject of formula. What we are doing is to apply the principle which says that if I'm adding, for example, if I have a quantity, let's say I have water, I have kerosene, I have gasoline, and I'm mixing it together. At the end of the day, they tell me carry another thing and put there. By the time I add up everything, it will definitely give me a new compound. Is it not true? Yes. I will have a name for it. The quantities or the elements I started with will not be the same again. It will give me something new. And if I'm subtracting, by the time I subtract, by the time I remove, whatever quantity I have there, that I'm removing, even if, let's say I've mixed gasoline, I have it, then I come and remove something from it. What is remaining is still the same quantity, the same compound. So that is the idea you use when you are treating this dimensional analysis. So you don't try to make it mathematical, trying to make subject of formula. It's more of reality than theory. So you have that in mind. So that is the second rule. Now the third rule, which will be the last, so that you can now start solving the questions we have there. The third rule is that the dependent or the subject formula, the dependent must be equal to the given values raised to unknown powers. So notice that in that question, if they ask me to find B, because of the fact that B is V minus B, it simply means that anything I have for volume, that is what B is. So since volume is L raised to power 3, B is also, yes. So the third one and the last one is that the dependent or the subject formula is equal to the product of given variables raised to unknown power. So let's take, for example, I'm given, let's say they tell me, I have a question where they say the volume per second of a quantity, the volume per second of a quantity depends on viscosity. Let's say the volume per second of a quantity, that question in your textbook, you see that this is volume per second, but there the purpose they missed it and they wrote volume. So the volume per second, that is volume over time, is dependent on viscosity, which is N. Now they come and say maybe I reduce, and maybe they put another thing like maybe pressure. Whatever they gave us, or whatever is given in that question, what we are saying is that we should find the one that is the subject formula. That is why I said the subject formula or the dependent is equal to the given values raised to unknown power. So I can choose to call the power here X, Y, Z. Another person can choose to call his or her own Q, R, whatever you call it. But know that the principle is that the given value, the dependent, must be equal to product of the given values raised to unknown power. And for the fact that I'm introducing this, notice that it must be directly proportional first. So in equality sign, I will introduce a proportionality constant, which is K. So these are the rules of dimension. These are the three major rules of dimension. So if I know this, is at this point that I've done this, that I can now start applying the first rule. So once I've gotten this now, there are cases where they won't give me the equation. So any question on dimensional analysis comes with an equation. That is what it means. And how do you find the equation? By making the dependent the subject of the formula equal to the product of the given values raised to unknown power. So once you are done with that, the next thing you will do after this is now to apply the first rule, which is trying to make the left-hand side to be equal to the right-hand side. Then solving the indices that follow it. Yes. And we know that anywhere you see viscosity, please, before you start solving for me, you need to know that viscosity is simply put as the product of pressure times inverse of velocity gradients. And I've told you before that anytime you hear velocity gradient, yes, we can define viscosity as simply the resistance to the flow of liquid. Is it not true? But in the calculation aspect, I need you to know that it is simply pressure and inverse of velocity gradient. Why? If something is resistance to the flow of something, it simply means movement in physics is velocity. Is it not true? And for you to move, pressure must be applied. Now, if you are resisting motion, it simply means you are going contrary to the velocity. So it's simply the product of pressure and inverse of velocity gradient. And what is why am I saying velocity gradient instead of velocity? Because gradient simply means that there's addition of lengths. That is why anytime you hear gradient of something, know that there's an addition to the length. We are not talking about slope. But anytime you hear, for example, pressure gradient, acceleration gradient, this one gradient, know that it will always come with over its length. Yes, there will always be a change. So if that be the case, note this for viscosity, so that as you are solving, we have no issue. All right, so if I point you, you come and solve. Starting from question 1. I think that question is up to, how many questions there? Check. Make sure you have your phone, and you're checking. How many questions do we have there? Just check the PDF. Please check. I posted it this morning. I want it to be an interactive class. How many? 11. Yes. I heard your voice. Come and do something for us. Choose. Well, I'm not the one giving you question, Shari, you know. My own is that when I call you, you look very well. Check the question you can solve there. Then you come and educate us. Make it very educative. Come. AI Da Vinci. Please call for him. Yes. You can come with your book so you'll be seeing the question. So please, however you want to do it, you can even solve it beforehand so that as you are coming, you will be looking at it as your guide.
Don't worry. You don't understand what you solve, but God will read you understand.
All right. So please, it's very interactive, and I want you to know that the reason for this is, or the reason we'll be doing classes like this is because in as much as we are teaching you, I wouldn't like you to just be copying notes. That's not copying. It's eating deep into you. Some of you just want to copy notes, you will read it at home. But if you can be able to learn it while we are in class, if you go, what you're just doing is to glance through, to put something on top of what you already know. I remember for everybody to define as not divided, but not each one. The less important can ask
have S R
AI Da Vinci. All right, so he tried, and I believe, is that the only marker I gave you? Okay, yes. AI is very sharp, but if you notice, look at what we are having here. If you notice, what he has succeeded in doing is to derive this equation for us. Are you aware? Yes. So he has been able to derive this equation successfully. This is how we derive this equation, that S is equals to UT plus half AT square. So, and that means he has proved that it can be derived. Is it not true? Yeah. But what we need now is to prove that S and UT is equal. Half AT square that is equal to S. So who else is going? Aya, come. You prove that S is directly equal to, you got it by deriving it, but you were not able to prove to us that S is equal to what is supposed to be, that at the end of the day, you have now when I left hand side, Gabi on my right hand side. Okay. So we've derived today, so that you don't derive again for us. He has derived. What you are not doing for us is to prove that S can be equal to UT plus half AT square. Oh yeah. So is that his own you are finishing up? So he started from the origin.
we have to prove that S is equal to U and S is equal to R. And we already proved that S and dimension of velocity L is right. So we're working on this. We have L minus 1 plus 1, right? Yeah. So that means L W T will have because minus 1 plus 1 and so that's L. So the next one will take half A squared. So here we have dimension of X as L and dimension of UT as L. So we have to do the same thing that we have dimension of S as L and the dimension of this one is L. So we can now work on this one as 1 over E times E. What's the dimension of acceleration? L E minus 6 now times E. This power of now we now have 1 over E times L E minus 2 plus 2 is equal to 1 over times L, right? Yeah. So we'll have L down over. So therefore we can take S is equal to U. Dimension here is L, which is equal to L. And also S is equal to half A. Dimension here is L, and here we have S over 3. Yeah. So we see now that L here, L here plus L over.
Please clap for him. All right. What's your name? Which department? Keep it up. He's in pharmacy. All right. He tried and he got it. Now, even the two here, there's no need putting these two. Do you know why? Because of this case that I mentioned. Thank you. Clap for him. Because, yes, because in dimensional analysis, figures, numbers, numericals are dimensionless. What we are just looking for is the alphabet. So that is why he's correct. So if you remove that 2, you see that even that half, even when he started, he's not supposed to go with the half. So you see that he's correct. So it has been proved that this side is equals to this side. And even without solving it, do you know why he brought this out? He brought ut out and brought half at squared out. Reason is because he applied the second law of dimension, which is the minute I see plus or minus sign, it means that everything I have here is the same. Do you still remember that time when we said for it to be added, it means that they have the same dimension. For it to be subtracted, it means they have the same dimension. So he's correct. He's very correct. All right, so please copy it. So he completed it. So, okay. Okay. So yes. So L is equals to L because numericals. So it's more like saying we are removing this because numericals are dimensionless. Numericals are dimensionless. So just like this, and L plus L, this is L, this is L. So it means that what I have here and what I have here is the same. No need putting the plus once I see the positive sign. So proved. Hence, proved. All right. So another person, check yourself very well. So AI and Victor, both of them, they've given us answer. So okay, you want to? Okay, Shadrach, don't worry. AI is the one that has entered my mouth. There are so many Shadrachs on campus now. Okay, don't worry. I'll find a way to be calling the Shadrach so it will still sound like AI. All right. So another person should make sure that when you are coming here, you are giving us a different answer. A different solving. Sorry, you are helping us with a different question. So the questions you will solve will no longer be among the ones that they have given us the answer already. So our point. Let's start. We pointed. Should be first a boy. So this time we're starting with Gian. Yes. Yes. Mary Jasmine, come and solve. Just check a particular question. Why I called you is you are busy, we are busy solving, you are busy writing. Don't worry, after you copy it, come and solve. Find your own question, come and solve. I will not clean this one. Use this part of the board. So you see how she went around to climb this step. Why did you follow like this? Well, so please pay attention to whichever question she's solving so that we can learn. We are learning. It's not just display, we are learning. Success. So question 4, go to 4A and be checking. Oma. Don't worry, you solve one for us. See, please, make sure you go through it. You will solve one for us. No, don't do we've taught anything. No. Just anyone you know you can clearly explain and solve. You come and show us. Make sure you're doing something. You are preparing for something while paying attention. You know. Welcome. Okay, your friend, he's not back. Okay. Okay, good. Welcome. What department are you? Biochemistry. Hi, Bana. These students are your classmates. Nkibiana. Up 100 level. Yes. I think so. Please, if today is your first time, I'll call my number now. You save it. The minute you chat me up, chat me with your name and your department so that you can get the group link. Once you get that group link, you join the group so that you can be getting updates. You know when classes are holding. No time for everything. It's meant to be a lively group. But you notice that most of the time, you open the group. Let me tell you the truth. You see that thing that is happening? Last night, somebody entered the group, tried to remove all the admins. Thank God that the creator of a group, they can't remove the person. If not, the case would have been different. So he tried to remove all the admins. Even some of the admins said that he called them. I was telling them, send me money so that I can make you admin. I can make you admin again. So if you check it, you see that Nigeria now is more like catastrophic. People are fighting for different means or through different means. So why am I saying this? As you come or as you're in that group, people can come to your DM to say certain things. And as a one student, if it's cheap, you want to do it. Maybe somebody can just enter and say, I am your course rep. This one, and you've not started school. You have to pay for this one, you transfer money for the person. The worst is that once you do it, they will block you. So please, you have to be very careful. The other day I was reading an article, day before yesterday. A man went to buy fuel. I'm coming. Then after they filled his tank, instead of paying, giving them money, he just drove off with people's fuel. Yes. So that should tell you that the country now is like so please be mindful. Are you done?
No, I'm just
okay. Is that all? Another thing I want you to note, thank God I just saw that. Do you know that naturally they always tell you density equals to mass over volume, right? Yeah. Yes. Please, I need you to know that density equals to mass over volume. And when you are using that volume of L3 or meter raised to power 3, is because we are thinking of it in terms of three-dimensional region. The case is just like when we did moment of inertia, where the volume we are talking about can be volume on a surface. Sorry, let's not use surface because when the surface is not area. Sorry, yes? Yes, it's not area. So it can be just volume of a rigid body. In that case, you're just using meter. That is, it's going to now be mass over meter. Are you seeing it? So don't be stiff on, I know that density is mass over volume. That is meter cube. That is, should be always meter cube. Yes, that is generally accepted standing. But when we are talking about volume in terms of looking at something that has just one dimension, what you are going to be using there is now just its length, which is applying meter in the place of volume there. Okay, let you stop here. Finish everything.
Okay, you said more we can.
Okay, the one yourself.
Yeah.
All right. So please, but if you notice this kind of question, if you are doing it, I'm not supposed to allow you to come with your book. This particular.
Oh, is it the question now?
Okay. So please, once you come here and I notice that what you are doing is this type, you will not use your book. All right. So please clap for her. Alright, so speed equals distance over time, velocity displacement over time, acceleration velocity over time, force mass times acceleration, area meter square, that is vertical and horizontal, volume vertical, horizontal, and the projection. Then pressure, force over area, density, mass over volume. All right, so with that said, I think while you are going through the questions, you will solve for me. Now look at the question. Which one do you find the most difficult there? Point it out to me. Let me solve. So if I solve that one, we'll go back to you coming to solve for me. Okay, number 5 and 7. Okay. So once I'm done with number 5 and 7, you will still come and solve again for me. So this one stopped at G. When I call someone should come and complete this one then, before the person will now solve his or her own. Oh yeah, read question 5 for me. Read it out too, by hearing. Okay, okay, no problem. But the van der Waals equation, just give me the figure there. Is it like this? Okay. 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 V over
N.
Okay.
Minus B.
Okay. Okay, equals to RT. Like this. Okay. Tell me, continue now. Okay. Is that all? Okay. So they say that I have a van der Waals equation for a gas. Notice that naturally van der Waals equation is given by P plus A over V square. Then we have V minus B equals to RT. This is the general rare gas equation that we know. But a situation when they gave us this one, we will not come and say, because they gave us, we know this one, that we can't do something with this one. Hope you know. So that is why we are not going to be using this. We'll simply say, okay, all the things I know about dimension, let me apply it to this question and solve. So for me to be able to do that, I will simply first of all simplify the A, so that A will become such a formula. So applying the first law of dimension, the third law of dimension, or is it the second law? So I will simply say that P plus A N all square all over V square will be equals to RT. And then V over N minus B will be equals to RT. Is it not what? Yes, now see. See now, this is AN square. I'm coming now. See, watch. I did the simplification. Since the square is for the both of them now, I now carry square and put for this one, carry square and put for this one. That is because these two are products now. AN square. A square, N square. That's how you want it, Chebi. No wahala. Okay. We are happy now, Shebi? Yeah. Okay. So if I know this now, I will now apply the law of dimension, which states that I have to know that anything I get for A should be equal to what I have here. The same thing with this. So before I can apply that law, I need to make a subject of the formula. And how do I do that? I'll try to get the LCM. So I will say the LCM here will simply be P plus AN square all over V square. Then take the LCM so that I'll have PV square, shall be? Plus ANO square. Is it not true? Then equals to RT. Alright. Notice that this V square, when I say, should I say take, you remember, this can just move over there so that I just have that what I'm focusing on is simply PV square plus ANA square. So I've thrown this one to that side. Remember that our focus is always on the one this side. So if I do that, I'm left with PV square plus ANA square. Sorry. I'm left with this. Now, you need to notice something. Notice that our A is having square and our N is also having square. Which means that whatever I'm having here, by the time I do this, notice that this part is having, let's do it this way, because if you want to make something subject of the formula, you have to make it in such a way that it will cross equality sign. Is it not true? But in this case, remember we said that we are not doing equality sign. But rather, our goal is simply on that approach of, remember, this is not, the equation normally is supposed to be A over V square. But we are going to be applying the approach of obeying our rule. And how do we obey our rule? We will say, since this thing, anything we get here is going to be the same thing with what we have here. But notice that this one is having AN square. The only way you can be able to make this a subject of the formula is by taking the square, after getting this, taking the square root of what you have here. Is it confusing? But see, first of all, let's say I have just AN. And I know that dimensionally, this being a product of this, I am not going to cross equality sign, because once I cross equality sign, remember I told you that in doing this, we don't try to start doing, let this one cross equality sign. The minute you start doing equality sign, it is no longer you applying the rule of dimension. That is what we are trying to adhere to here. Our goal is simply, how do we find the dimension of this? Once we find the dimension of this, it is the same thing with this, because this thing, they are product, these two are products of each other. This one are product of this. That means that if you're adding this product and this product, it should give you the same thing with this one that you already know. So when we do this, using that our principle of pressure to be, okay, let me just solve. When I finish solving, you see. So force over area. This will give me ML T minus 2. Should be? Then all over L square. This cancel this. So that I'm left with M L raised to power minus 1, then T raised to power minus 2, right? Now, I know that volume square will simply be L raised to power 3. Now, when you square it, it's going to be L raised to power 6. So when you put it together, you now have PV square, PV square, okay, let's do it this way, equals to ML raised to power minus 1, T raised to power minus 2, then I have my L raised to power 6, minus 1 plus 6. So I have ML5 T raised to power minus 2. All right. Now when I'm done with that, let me just come and put it here. This is going to be simply ML5, then T raised to power minus 2. Then remember that this one is square, it's carrying square. I removed the square because I was explaining something. Then plus AN square. AN all square equals to RT. Alright, so what I'm saying here is that the minute I get this to this point where I've gotten PV square, that everything for AN square here is simply the same thing as MLT raised to power minus 2. Because that this thing is plus, I told you that in plus, whenever you see plus sign, for the fact that you are adding these two things together, it simply means that what I have here is the same thing with what I have here. That is it. It's having square, and this one is having this value. Because of the fact that they are being added, the dimensions are the same. So I will not come and be employing mathematics knowledge of saying let this one cross equality sign. The only mathematics I can simply do here is simply saying since this one is square, if I want to go further being mathematical, I will say since this one is having square, for you to get anything to have its subject formula as just a, you just say whatever this one has is now going to be raised to the power of 1/2, which is square roots. So, but at the right approach, this is just where you are supposed to stop and solve for this question. Just NL5 to the power -2 plus AN square. Somebody will want to ask me how. Remember that in dimension, we are looking at quantities. Those two quantities are combined. They came as a product. The other one, we know it's a product of volume and pressure. We already know it. So by the time you mix the two of them together, it simply means that it will give you a compound that is the same thing. So if I know that we say that whenever you are adding dimensional quantities, that it means that they are the same, and whenever you are subtracting, it means that they are the same. So this is where you are supposed to stop for this answer. So which means that it is simply going to be the same thing as just saying AN square is equal to NL5T minus 2. That's your answer. Remember the first approach, the first one we solved, when we used Rey-Gas equation, and we got that A is simply this. Yes, we are looking for A, and if we are looking for A, the approach we are going to be using is the rule of dimension, not the mathematics I know you want me to do. See, what you want me to do is to say this divided by n, then raised to power 1/2. It is not possible. I will not teach you to prove mathematically and then neglect the law. This thing now cannot be divided by n, then raised to power half for the square root. So remember the rule. Once we are adding, the dimensions are the same. Once we are subtracting, the dimensions are the same. So this is where we are stopping for this question. That is it. It's very correct. Reason why we solve is because of the fact that they gave us this to be raised to power 2. Naturally, even you will see that the complication is coming from the fact that the natural equation for a Rey-Gas is simply P plus A all over V square. Then V minus B then equals to RT, which is that first one. And when you do this, you see that by the time you do it, you get everything to be in order. So in this case where they manipulated the question, you will still get to the point where you still have to pay attention and show them that yes, you understand the rule of dimension. So that rule of dimension is what we are adhering to. If not, we could have just said, okay, let this one cross equality sign. Then we'll now come and start doing nonsense. No. So this is where you are stopping for this equation. So it simply means that AN square is what you are giving the answer for, not A. AN square is going to be the same value you have for PV square. Very simple like that. Yeah, we'll solve for B now. We just finished for A.
Now, what's your final answer?
We've not solved for B. We just finished for AN square. Please, do you remember when we solved this one? This one now. What did we get for A there? The same thing, Shebi. The same thing. When we solved this one, you notice that it was easy because we easily did V square and everything is coming towards one side. Now, when we get to this one, we cannot come and do divided by n. No. What we obey is simply, for the fact that these two things now are together in this ratio, it simply means that whatever I have for this side is the same thing with what I have for this side. The dimension of this is equal to the dimension of this. That is the principle you obey. Not that you're mathematical reversing it. That's the principle you obey. So that is why they manipulated that question. That equation was manipulated. If you check the equation of a Rey-Gas, this is the equation. But that equation was manipulated to make you have this idea so that you retain it. Now for the V, they gave me V over N, should be minus B equals to RT. So let's try to solve something here. Notice that this will be the same thing as saying, take the LCM, I'll have N. So if this goes, it becomes V minus Bn equals to RT. Is it not true? Cross multiply, you see that this will simply be V minus Bn equals to Rtn. Remember I said that whenever we have this addition or subtraction sign, we don't have business with trying to make the left hand side and the right hand side to be equal. Our business is simply proving that whatever you are adding and whatever you are subtracting is the same. Notice that once you have a dimensional quantity, I think this is the best way to put it. Once you have a dimensional quantity adding or subtracting, what you are proving there is that those things that are adding up are the same. And those things that are subtracting, that they are the same. While once you have a dimensional quantity equal to another one, what you are trying to prove there is that the left hand side and the right hand side must be the same. So when it's adding, when it's subtracting, what you are proving is that those quantities are the same. When it's on the left hand side and the right hand side, what you are proving is that the left hand side and the right hand side must be equal. So that is the reason why when you are solving this, you don't have to be mathematical more than obeying the rule. Because this is more practical. You are trying to prove that if I have two quantities and I'm adding it up, when they form a compound, those compounds must be the same. When I remove something from a compound that is already there, what is remaining is still the same thing with what is outside. That is what you are proving in this case. So if I know that, so this is where I'm focusing on V minus Bn. So this is volume, which is L raised to power 3. Is it not true? Minus Bn equals to Rtn. I have no business with this, but I'm carrying it. So for the fact, obeying the rule, for the fact that this is being subtracted, Bn in this case is equals to L raised to power 3. This is where I will stop. I will not come and say L3 all over N. I will not come and say, using that your normal mathematics, now trying to make this to be divided. No. What I'll simply say is that this B came as a product inside this. So it simply means that inside this volume that I know, there is Bn, a product of this B and N that is inside this. So for the fact that they are being subtracted, what I'm checking is, are they the same? So I'm not going to be doing L3 over N. Rather, Bn is equals to L3, is equals to volume. That is just what I'm doing there. So please note it down however you want to write it. Whenever you have right hand side and left hand side given, you must prove that the dimensions are equal by saying m raised to power 0, l raised to power 0, t raised to power whatever equals to the same thing on the right hand side. But whenever you are adding or subtracting, what you are going to be proving is that whatever you are adding and subtracting, that they are the same. Very important. Very, very important. All right, let's move to the next one, number 7. Can I clean? Number 7, read number 7. You are not supposed to be confused. Ask me. Yes. Is it for this one? S equals to ut plus half at squared. See now, this thing is it not just S equals to LT minus L over T for you? L over T should be times T. Is it not true? T cancel T and S is in L. Is it not true? L is equals to L. Now S, which is L, equals to half L over T raised to power 2, then T squared. This cancel this. Half, that is 1 over 2, has no business with dimension. L is equals to L.
Let's say your word for it that yes, equals to L. Because from this point now, I don't know what
from this point, see, do you notice that, notice that, assuming for example, I am not focused here. Let's say I'm not focused here. Let's say I don't have S, which is on the left hand side. Let's say I am solving just for this. Let's say I'm solving for this, which is ut plus half at squared. Notice that the minute I get L this side, I get everything here to be L. If I want to solve for this one, what will I be doing? I'll be trying to say, let's say I now have ut. Let's say I've gotten everything here to be L, Shebi. I will simply say that ut is equals to L. Are you saying it? I will not come and say ut equals to L. Then I will come and say divide both sides by t. it is madness. Are you saying it? Yes. So whatever you get at this point, even if you like, let it be long products. Your business is simply to obey that for the fact that they are being added together. I have nothing to solve further. So as I've gotten BN, yes, we don't know BN, but in this case, we know what U is, and we know what T is. In this case, where I have BN, it could also be U, it could also be T. So in this case, I'm not solving further. I'm just going to be making it to be equal to that thing that is adding up. If you solve further from there, you've missed the whole thing. So that is why I said that once you get to the point where you've been able to put this to be equal to, you've been able to simplify the part that is with it. The other part is equal to it. Just like that. You are obeying the rule, not the mathematics. Not just to solve mathematics here. Because this one is more practical than just solving mathematics. So that is it. So please, read question 7 for me. I want to believe that we've cleared the air. I want to believe that you understand it now. But read question 7. So that you can now solve your own. So they manipulated that equation in order to know if you will obey that rule of dimension or not. So if you want to know it, you still see that even you bringing out this thing for us even helped us very well to throw more light on it. So please give me question 7. Oh yeah. V is equals to, is it small r or capital R? Okay. Like this? Okay. Is that all?
Yes.
But read the question from the beginning. Please, hello, make sure that as you are in this class, see what I want you to do for me. Once this physics class we are doing this semester, just pay attention. That one that you want to argue with, have it in mind. The one that you are learning from me, have it in mind. The minute we finish, you are now bringing your own arguments with the one you already know. So that as we are cancelling it out, you are dropping it from your mind. Till you drop it completely. I'm going to read the question from the beginning. Okay. Okay. Full stop. Answer the velocity. The question given to you, they said that the velocity it depends on radius, Shebi. Then it depends on pressure. Then it depends on viscosity too, right? Then they now tell you that using the method of dimensional analysis, once they tell you using the method of dimensional analysis, there are 3 things that should come to your mind, which is the 3 laws, the 3 rules I've given you. Which is the first one, left hand side must be equal to the right hand side. The second one, if I have anything like plus or minus, it means that I will make it to be the same. Then the last one, which is what? What's the last one? What's my last rule for? You are looking at my what I've given you there. Now, that one you are reading is already on the board. That's why I'm asking you what's my last one. Notice that the minute they said dimensional analysis, method of dimensional analysis, I rush to do that dependent to be equal to product of everything there. That is the radius that I'm giving, the pressure, and the viscosity. Now that I've done it, I will now come and raise it to power x, power y, and power z. Don't get deceived. These questions that you have there are exam questions. So somebody will easily see this particular equation and think this is the equation for the whole thing. Forgetting that using the method of dimensional analysis, you ought to prove the 3 laws, which is I've been able to make this to be equal to the product of the given values raised to an unknown power. Once I'm able to solve for this, making sure that the right hand side and left hand side, notice there is no addition here. So I'll make sure that the right hand side and left hand side is equal in this case. Once I'm done with it, I will now go back and check this particular question that I'm giving, this particular equation. What they told me in this equation is that I should use this equation to make the constant, the dimensionalized constant, which is k, the subject of formula. So see what I mean. For the fact that I've been given this, I know that this is directly proportional to this. Anytime I have something equal to, there must be a constant of proportionality, which is r now x, p, raised to the power y, and raised to the power z. If you want to make your own power, let's say you want your own powers here to be like m, n, j, anything, no problem. Me, I'm using x, y, z because I know in physics, this is what we normally use once we are talking about dimensional analysis. Now that I've gotten this, your goal now is to make everything here to be equal to what you have here. Once you are done with this, you now go back to this equation. So please always read the question. Whether they did not give you an equation, you know that you must obey the 3 rules of dimension before even looking at any equation given to you. The only time you look at the equation is when maybe applying the rules of dimension, you notice that the equation you have is the same thing with what is given to you. But once it's not the same, you obey the laws of dimension. So dependence must be equal to the product of given values raised to unknown powers. So I will use it to solve now. I know that radius, the dimension of radius is L. So this will be X. I know that pressure is force over area, Shebi. I will normally get it to be the same pressure gradient. Read the question again. No, read from the beginning. See, the gradient they are talking about is this one. Because see how I know. You said the velocity depends on pressure and radius. Is it not true? Yeah. And then you read something about viscosity again, right? So I have no business with pressure gradient in my products in this equation. Assuming they said the velocity depends on pressure gradients, radius, and viscosity, that's when I will use the pressure gradient. But here, in this equation already that I'm seeing, when I see P over L, it simply means that pressure gradient is there because anything divided by length, any quantity I know divided by length is simply the gradient. If, as I'm seeing this R square here, if I don't want to consider this P, I can also say that if I'm not considering P and I'm considering R, I have radius gradient here because I'm seeing R square and L. So, but the main thing I want you to get is that any dimensional analysis question, once it's given to you, your focus first of all is to obey the 3 rules of dimensional analysis. If you did not see plus or minus, remove that particular one. You are just making use of 2 compulsory rules that you must obey. All right, so I have pressure always giving me, Shebi, ML raised to power, is it minus 1? Shebi, force over area now, that is ML raised, Shebi, all over L square. Yes, so by the time you push it up, it becomes ml raised to power minus 1, then t raised to power minus 2. Now viscosity, we said that viscosity is the product of what? What did I say viscosity is? Hey, who don't need to query this sharp? Once I say it, you master it. So I said that simply put, we know that viscosity is resistance to the flow of liquid or fluid. So we said that mathematically it is the same thing as product of pressure and inverse of velocity gradient. So this is going to be simply the same thing as saying I have pressure then times 1 over velocity gradient, which is the same thing as saying L over V. Hope you know that inverse of something means reversing it. So this is now going to be velocity is the same thing as saying LT minus 1. So this is now going to be the same thing as saying M L raised to power minus 1, T raised to power minus 2. Then this can take care of this. Is it not true? So I now have that this side is the same thing as saying 1 over T raised to power minus 1. Hope you know. And I know that once 1 is the numerator, this is now going to be the same thing as saying T minus minus 1. So that this now becomes, if it's coming out, so it becomes T like this. Should be a saying. So there's 1 here. So 1 minus 2. So ML minus 1, T minus 1. So for the velocity, for the viscosity. So notice that everything here for pressure is carrying Y. Then, for viscosity, I want to clean this so that I can write it. Once you learn it, it won't be that stressful for the person saying, now, wow, it's looking plain to them because you are still learning. Have you not noticed something about anything you are learning? Once you are learning something for the first time, because you are just meeting it, it looks as if it's big deal. But the minute you keep meeting that thing, it becomes normal. Yes. So as you are meeting it now over and over, it will become normal to you. All right. Now, everything raised to power Z. Then I have my K. I have my, okay. Now, velocity here is going to be LT raised to power minus 1. Hope you know. All right, now let's now simplify so that I now have L raised to power X. Then M. Then I have L raised to power minus 1. Notice that this M will carry distributive power law. Anything that is the power, we get all of it. So M raised to power Y minus 1 times Y will be minus Y, should be. Then T minus 2 will be the same thing as times Y with 2Y. Yes, I'm done with this bracket. Now the next one times M raised to power Z. Yes, then now once I'm done with this, let me still write this one. So what I'm going to be doing here now is simply mathematics. I've seen some textbook when they want to include the laws of dimension, they will be including all these things we are going to solve. It's not among. We just have 3 major laws of dimension. This one we are doing here is mathematics, collect like terms, or you say products rule in indices, which is when the bases are the same, add the powers. So for the fact that I see that here I have L, I have X, then I have minus Y, Shebi? Then I have minus Z. So we are just doing indices. If the bases are the same, add the powers. That is why if you've not learned indices, it's important. You can learn it. And I believe Master Taka will still teach it. Now, next one is M. I have M, then I have Y plus Z. Any other M here? Then the next one is T. Then I have my T to be minus 2, Shebi? Y. Any other T? Minus Z. Then notice that this side is simply LT raised to power minus 1. Is it not true? Look at it now very well. So, don't worry, we are getting to that. Don't worry, we are getting to that. So notice that at this point that we've been able to simplify everything, we now need to check my left hand side is equal to the right hand side. My left hand side is having M, having L, and having T, but it's not having, my left hand side is having L and T, but it's not having M, Shebi? But right hand side is having everything. So I'll simply say, let me add M raised to power 0, because anything raised to power 0 is 1. And 1 times LT minus 1 is still LT minus 1. So once I've done this, I can now go to the next rule, which is equating the basis. So equating the basis, I will now say for M, I will now say for M, on the left hand side, what am I seeing as the power of M? 0. On the right hand side, what am I seeing as the power of M? Y plus Z. Let's do for L. On the left hand side, what am I seeing as the power of L? 1. On the right hand side, what am I seeing as the power of L? X plus Y. Okay, minus Y minus Z, like this. Okay, let me just bring this my Y and Z this side. Should you notice that when you are learning something, you should be learning the pattern that is flowing, because I've seen something that will happen there. Oh yeah, for T, what do I have on the left hand side? Minus 1. Then right hand side, what do I have? Minus 2y minus z. Is it not true? So now that I'm saying this, what I want to say at this point is, notice that I have nothing as subject formula, but I can easily say in this one now, here, this one, I can easily say making, because I'm seeing y here, Shebi, seeing y here, and I'm seeing z, but I'm not seeing x here. Is it not true? So I can choose to make any of this subject formula. So I can choose to say y equals to minus z, or z equals to minus y. Hope you know. Yes. Anyway, I do it. I don't have issue. But notice that at this point, let's say I call this one equation 2. Call this one equation 1. That means that equation 3, sorry. That means that this one becomes equation 1. And because some people don't know simultaneous equation, once you start putting equation 1, equation 2, their mind will change. So please, what I'm saying is this. Notice that these two things, this equation 2 and equation 3, I can just say add them up. Add them. And if I'm adding them now, what am I having? Yes, now I can add if I want. I can add. So let's do it. Let's do 1 minus, that is 1 plus minus 1. What am I having? 0, Shebi? Is it not true? Then, I don't have anything for x. Let me just bring my x down. Then, minus y plus minus 2y. What do you have? Minus 3. Minus 3y. When minus z plus minus, Shebi? Minus z minus plus minus z. What do you have? Minus 2z. Are you sure? Okay. Somebody said we should quit. Let's. Okay, we should substitute y in equation 3. I know, but I want us to, I think, even before substitution, using that our elimination method will still work. If I put it for equation 1, let's say I put equation 1 against equation 2. Will it not work? Okay, I'm seeing y here, Shebi. I'm seeing y here. Okay, no x. Yes, if I put this against this, it will still work now. Don't worry. Don't worry. Yes, if we want to substitute, we can substitute. But I'm thinking of what, in an exam hall, what a student will want to consider first. Okay, you're considering substitution first. Are you sure? Let's consider substitution first. But please, that is the way I do my own teaching. I normally think of it in a way, let's say I'm the one in the exam hall. What are the students used to that they want to think of first? So if you think substitution is what we are to use first, I can say, carry this minus y. Anywhere I see z, I replace it with minus y. But I still think this one, if you are type that can think well, you see that this one against this, if you check it trial and error, you must find something that will make these two cancel out. So let's say we carry equation 1 and substitute in equation 3. So that I now have minus 1 equals to minus 2y. Then I have minus for z is having minus y, Shebi, which is plus y minus 2y equals to minus 1. So minus 2y plus y is what? Minus y equals to minus 1. And I know that I can say divide both sides by minus 1. Is it not true? Or say cancel, cancel. So y is equals to what? 1. Yes. Now, if I've gotten that, I can still come back here and say since y is equals to 1, z will now be equals to minus 1. Is it not true? Which is just minus 1. Alright, that means that all I'm left with now is to find x. Yes, in equation 2. So I can simply say this is 1. If this goes over my plus y plus z equals to x. Okay, so I have 1. My y is what? 1, Shebi? My z is minus 1 equals to x. So x is equals to 1. Alright. So if I've gotten this, are you aware that I will not stop here? Hope you know. I'm not going to stop here. I will simply say, okay, since I've gotten X and Y obeying the dimensional analysis rules, let me now have an equation for this. Using the formulas or the answers I have. So if I do it very well, you now see that I now have if you do it very well, you see that I now have V to be equals to K R. My X is what? 1, should be checking, oh. Then my Y is what? 1. And my Z -1. Okay. Is -1. Okay. So that means that V is actually equals to, if you check it very well, you see that this is the something that's saying KRP, then 1/n. Are you aware? Which is the setting as saying KRP/n. All right. So we've been able to get the value of velocity using dimensional analysis. So what we are now going to be getting is the value of K using that equation. And for us to get it is simply comparing the two. I want to clean, can I? All right, so see, I can now say, read the question again, so that we get the part where we are finding for K, the dimensionless constant, so it doesn't look as if it's magic we are doing. Okay, obtain, no, read from the beginning, so that as you're reading, I'm analyzing what you're reading.
Velocity for the streamline flow of the liquid depends on the radius R of the density and the coefficient of viscosity. Use the method of dimensional analysis of obtain an expression of the velocity, given that V equals to R squared over 4n.
Wait, I want to get something. The question you just read, I had you say velocity, density. Yes, I had you say density, not. Is it? Yes, I had you say. So who is even reading for us? Initially, you gave me pressure. Then now I'm hearing density.
The mistake was from the formula that we use like that. It's lower, it's not.
No, before even that, you gave me pressure. Because see, first of all, see, if you solve this thing using pressure, that means this is the answer we are having. But notice that what he just read, he called density P. Which means that if we are applying to this, at the point where we solve this P as pressure, what we are supposed to solve it as is density. Or still solve it as pressure. How the Kimano exam can I prepare for? That is why, please, when we say read, everybody join and read. Deacon, I see. If I have V to be equals to K, R, so that thing is not P but rho. So I have rho, then I have viscosity. So I have X, Y, Z. The good thing is that the more we do this, the more you are learning, as far as you're paying attention. So me that is teaching, I'm not complaining. V equals to K, then I have L raised to power X. So since its density is going to be mass over volume, and this is simply M L raised to power minus 3. Very simple. So M L raised to power minus 3, then I have my Y. Then viscosity, is we've solved for viscosity, so we don't start solving it again. Give me what we got as the dimension for viscosity. That is when we did product of pressure and inverse of velocity gradient. What? ml minus 1 all raised to power z. Okay. So you see that you have k m raised to power x, m raised to power y, m raised to power minus 3y, m raised to power z, m raised to power minus z, c raised to power minus z. Oh yeah. So this one is the sentence as saying LT minus 1 equals to. So you know that this can be the sentence as saying m raised to power 0. Then, so I now have k. At this point, I want to collect like terms. So L x minus 3y shall be minus z. Then I have m y, all the m plus z. Then what about t? Is only one t I have. Shebi? Okay. Which is minus. So you see, sometimes God take you around the mountain to bring you to where? A very comfortable place. So you see that all those things we did, it looks tasking, but if you pay attention, as we are doing this one is very simple. So it will guide you. So that is why they say practice, practice, practice makes permanent, not perfect, but it makes it part of you. All right, now let's see. Collecting like terms, we then see that, or we say equating the basis. Equating basis, we can say for m. For m, I'll have 0 equals to y plus z. Then for L, I'll have 1 equals to x plus 3y minus z. This time around is elimination we use, it's not substitution. Reason is because I like it to be that you learn all the methods, so that when you go inside the exam hall, you don't have any reason or any excuse. So I've gotten for L. Then for T, I have minus 1 equals to minus z. Okay, this one is even on its own, no need stressing you. So z is simply equals to. Okay, you've solved it. Okay, minus thank you. Don't worry. Once it's by this time, sometimes you miss some, you get some. Oh, yeah, see? Yes. Now, see what I will do now. I'll substitute here, inside here. Y can be the same thing as saying minus z, Chebi. Is it not true? So, y is equals to minus 1. So, if I know that, I can make x out of the formula here. So that x now becomes, and thank God we're in front of camera. Imagine us solving rho as pressure. Thank God. So we now have x to be equals to plus 3y, then plus z. Hope you know why. So I now have x to be equals to 3 into my y is minus, then plus 1. So this is going to be the same thing as saying x is equals to minus 3 plus 1. Isn't that true? So x is equals to minus 2. Please check and... Hey, Jesus. Shall we this? Why is minus 1 now? Is it not?
That is 1 is equal to x minus 2y minus 10.
See now, see. See. Watch, see. This is x. Okay, 1. Okay. It's true. I forgot. I didn't see the 1. Yes. So it's supposed to be plus. This is 1. Plus 1, Shebi. So by the time you do it, you see that you now have minus 3 plus 2 now. Is it not what we have? Yes, now. Because see, if this one crossover, it becomes 3. Crossover, it becomes plus z. This one is plus 1 that is there. So it's simply going to be, yes, it's simply going to be minus 3 plus 1 plus 1. which is equals to minus 1. So please check it, we should be correct. So once we are done, we can now come back and substitute. So this is going to be the same thing as saying R equals to minus 1 for X, rho equals to minus 1 for Y, and viscosity equals to 1 for Z. And remember, we have our K once we introduce equality sign. So that V will simply be equals to K 1 over R, then 1 over P, 1 over rho, I beg, then our viscosity. So that V is equals to K viscosity all over R rho. So that is what we have. That is what we have, and this is what is correct. That is what we have. So if I know that to now get the dimensionless constant, I will now equate. So please copy this. This is the correct answer. Can I clean this one? No. Be fast, be fast. Be fast. Are you following? Why? What are you doing? And what? I'm coming. See. Remember, when we are solving this method of dimensional analysis, we've been able to get our V. Now they say that in when we are done, that we should get the value of K. Notice that there is no K in this thing you gave me now. Is it not true? This is where you have K. Shebi, you have K by the fact, by natural right of the fact that if something is directly proportional, by the time you introduce equality sign, you must have K. If you are finding dimensionless constant, we cannot find dimensionless constant here. But remember that V is equals to this. So we cannot say, if we have V here, where do we have K? In the V that we can bring here, this V is equals to this. If you carry this and replace this, then you now make K subject of the formula. Are you saying it? Yes. So that is why I said when we started, the problem, do you know the problem? If you refuse to see things the way it should be, some people, the idea is that you want to force it. Because you've seen equation, let us use an equation. Or let there be a manipulation that as we are doing it, it should be turning. No, in physics, you cannot even manipulate. Because anything you do, if you finish, you will see 1,000 ways of solving that thing to prove if your answer is correct. So you are not solving to manipulate. Assuming they wanted you to manipulate, they will just put K there for you. You just make K subject of formula. No need stressing ourselves. But for the fact that I don't have K, I must use method of dimensional analysis to find a value for V, and that V will have K. So when I equate now, I can now make K subject of the formula. So it's not hard. So the only problem I have with some students is that we've not solved anything. They're already bent on seeing things in their own way. As I'm trying to put them out of that way to see things in my own way. You know that physics is something that as you are solving, it also involves some certain level of insights. Yes, there must be introduction of new things to it. So but when I'm doing it and you are insisting on a pattern of something you know, we'll be having issue. So now I'm given that there's an equation given to me that V is equals to R square P. And notice that they said that this P over L is pressure gradient. Is it not true? So what I have here is actually pressure. What I have here is actually length. All over 4 and viscosity. Then I now have that I should find the dimensionless constant, and dimensionless constant is K. And from this equation given to me, I've been able to get that V is equals to K viscosity over RP. So I will replace this V with K, then viscosity all over R and rho equals to R square all over 4. Then I have my viscosity. Then please notice that what I'm giving here, that P there is not density. Hope you know. Are you aware? So I will easily or peacefully. You say? No, now this equation, I'm giving this equation. This is the question I was given. Check that question. See, you must pay total attention in order to understand what we are doing here. There's an equation given to us. And in that equation given to us, what they say that we should find is K, dimensionless constant. But they did not give us K in that equation. Then they then told us that there is velocity that involves viscosity. And that after doing everything, that we should use the method of dimension to find that velocity, what is happening to that velocity. And when we finish by method of dimension, we got this, which is K viscosity all over R rho. This thing here is for density. So when we are through, the only reason why we want to associate what we've gotten here with this is because this one does not have K, and we already have velocity that has K in it. So by the time we equate the two, we can be able to get an expression for the K that they are asking us. That is the reason why we are associating the two. So what I'm saying is that as we are pointing these two things out, you need to know that this thing here is not density. Because in the question they clearly stated that P over L is pressure gradient. So if you like, you pay attention well and you understand. If you like, be paying attention half and half. If you switch on, you remove mind. Switch on, you remove mind. You will never understand properly that way. You must be here fully. If only you want to think of something else, you tell yourself, it's like I'm thinking of something else. You pay attention. Which happens even when you are reading sometimes. If you are reading, all of a sudden you switch off, your mind is thinking of something else, you will not follow. You'll be spending much hours reading that thing. So you must be here, fully here. Alright, now see, to make n subject of the formula here, I can easily say cross. Remember that my goal is to make this subject formula. Do you remember? So that I can get an expression for this. So I can say cross, so that I have K, and I could have said, let me just leave this, but let's do it together. Equals to, let me take this, R square. Then, remember that this one has this here, Shabina. R square, then pressure. This one is pressure. Let me write this one as rho so you understand it. This one is rho. This one is pressure. Then it has over L. I'm just bringing this thing, everything here down. Then I'm replacing V with this value I've gotten by dimensional analysis. So if I do it, hey, AI, class, is that what you heard? Class, did you hear me say we should remove this? You think so? I never said that. Please, it's not a joke, but we need to be here. And if you notice, I make room for my class to be such that we are not rushing it, but you must understand it. Please, this is an equation that I'm giving. This is an equation I'm giving. Then the V that I have here, since I don't have K in this equation, I've gotten V and V has K in it. I'll replace every value of this answer that I've gotten here for V. So what I'm just doing is, how do I cross multiply this so that K will become subject of the formula? That is just it. To make an expression for K, there's no such thing as solving or stressing myself again for it. So I have this all over for viscosity and L. So you see that when this one move up, you now have my rho. My rho, and notice that this is R, this is R. If it's going up here, you see that it can easily multiply this so that I have R cube. Are you saying it? Yes. Then notice that I now have, assuming I move this one, I now have N. I know that for this to be solid formula, I have to remove this N. So, which is for viscosity. And when it moves down here, it will come and see another viscosity here. So it will simply be viscosity square. Then I have my L. So please, this one here, this is my rho. And this is my pressure. So that this is my pressure gradient, this is my rho, and this is my R cube. So for this expression of K, this is my answer. That's just it. Yes. So that's just the answer. So it's very important. And please, when you are writing your own, however it is you want to do it, so that you don't confuse rho. So you don't confuse rho with pressure. Yes. So you don't confuse rho with pressure. Do you know that understanding is something that requires humility? Are you aware? Yes. Why do I say it requires humility? Most of the things that if you hear somebody say and you easily learn it or you easily understand it, is simply because you somehow subconsciously already know that thing. What the person is doing is just to remind you. And whichever thing you are learning that looks as if it's taking you a bit of time to assimilate is simply because it's new to you. Whenever something is totally new to us, we take a little time to put it in our understanding dictionary. And once it's there, we flow with it. The knowledge you already have is that whenever you are given something of dimension, how do you make left and right hand side to be equal? And once you make it equal, you simplify, which is the first process we did. You get your answer. But this one now comes with an introduction of something new that you've been able to simplify. Then how are you able to get something you don't have in an equation that is given to you? So just logic, carrying something to replace V, then make that thing that is there, the K you are looking for, subject of formula, simple. So that is what we've done here. So it's more like an introduction, especially on these parts. So once you're able to do this, go home, start looking for questions like it. Even inside the past question, you see that by the time you do it 1-2 times, it becomes part of you. Which is why I normally tell students that study. Some persons go to dictionary to look for what is the definition of study. But study is simply making reading a habit. Once it becomes your habit, the first time you always go to something, be it a skill, anything it is, the first time will always be hard. It will look as if it's a big deal. You do it 2 times, 3 times, even you come and give it like 6 months, you become master in it. So that even without looking at it, you are doing it peacefully. They wake you up, it has become second nature. That is how everything in life is. You must make it a habit. That's where people now come and say, you now have steez. You now becomes part of you to an extent where you now call it steez. Is it not true? Yes. Some people call it finesse. You finesse on it. Anyhow it is, you must have idea of what it is all about. So this thing is not hard. The only thing is that you will go home, make more research on questions that involve you applying the laws, and then when an equation is given, you interpreting to find for the dimensionless constant. So with that said, I want to point somebody out to come and solve for me, because that's our agreement. Now once I solve 5 and 7, you help me with the remaining ones. What's the time? 1:31. Okay, I want us to dismiss by 2 today. Okay, that was not the agreement. Because we have to do something now. We have done. Okay. Now see what we do. You go home, take your time to go through the questions, because tomorrow definitely we must solve. Are we together? Yes. It's not about you, maybe you sit down peacefully. One of the things that happen to students is that this thing you see when you are writing something, when you are bribing, you are bribing yourself not to pay attention. Because you'll be telling your mind, as I'm writing it down, I'll have time to go through it and I will learn it. That's bribery. But the minute you are learning it in class and practicing it in class, you have no other option. Which is why you see some students, even when a teacher or a lecturer is teaching, or a tutor is teaching, in your mind as that thing is flowing, your memory is telling you, this thing looks like something I can learn. It looks simple. My understanding is telling me that I can assimilate it. Yes. But guess what? If you don't go immediately to put it through inside you, the more you give it time, it will be going far away from you. It will be going far away from you. And when it accumulates before exam, you now say you want to come and read everything together. You see that it's stressful. That joy you had the initial time, where you were feeling that it looks like something you can learn, will no longer be there. You are now forcing it. So the first thing that you must do with regards to everything we are doing in class is making it a habit. As we are doing it here, you practice. You practice. You practice. It becomes part of you. Even when you're in secondary school, if you went to a good school, you notice that any time that you start and you're always doing your assignment yourself, you don't have to copy from anybody. You always come out first, second, third. Is it not true? But any time that you have to wait, inside class you copy the assignments. You copy everything. Exam, you must be like 40-something. That's the nature of everything in life. So please, let's stop here, but go and do the practice. Revise it. Have it in mind that tomorrow, everybody must solve something. All right. So please, somebody should pray for us. Somebody should pray for us. Let us go home. So we said that so far so good. We'll be starting class by 9 every day and ending by 1 or 2. Because tomorrow we might end by 2. But 1 is the agreed time. So please make our time to be following classes up. You see that once you go home and read this thing that we've done today, you even be discovering your own methods. What you now be saying in your mind is, even this my method is even better than SARS own. Because that's what they call initiative. Once you go home and as you are reading this and practicing it on your own, you'll be discovering your own methods. So please, go home, discover your own methods. So let us pray. Let us pray so that we can go home. Let's pray now. Let's stand up and pray. Success, pray for us. I wanted to call you for questions today. I did not call you. So now I'm calling you for prayers. I pray for us. Yes.